Okay, yeah. So let us quickly start with SJF now. Okay, all right. So let's do SJF. Now SJF is again a non-preemptive shortest job first. So whichever has a lesser burst time here, that will be given the first opportunity to schedule. Right. So again, let's draw the Gantt chart here. So this is a Gantt chart using SJF. There are 5 processes. Gantt chart starts at time 0. So at time 0, right now there's only one process available. So irrespective of whether it's short or not, P1 will have to be scheduled. And since this is a non-preemptive version, so the process will be voluntarily allowed to continue its execution until it finishes off. So P1 has a burst time of 10. So it will complete at 10. Now in the meantime, okay, so current time is 10. And in the meantime, as you are able to see, P2 and P3 have arrived. P4 and P5 have not yet arrived because the current time is only 10, but they have an arrival time of 12 and 18, so they are scheduled for a later point of time. Now, nevertheless, we have P2 and P3 already arrived, but among P2 and P3, P3 has a lesser burst time in comparison, as you're able to see here. Okay, so P3 has burst time of 6, whereas P2 has 7. So P3 will be scheduled first. So P3 will be given the chance to schedule first because of the shortest job first that we are using here. That is the condition in shortest job first, right? So whichever has the shortest job, that will be scheduled first. Now, unlike the first time where we had at time 0, because P2, P3, P4, P5 have not yet arrived at time 0. So P1 was the only one. So we had to schedule P1. Now, once P1 started, because it's a non-preemptive, it continued till 10. Now, because the current time is 10, in the meantime, we are assuming that P2 and P3 have also arrived. So among P2 and P3, P3 has a better burst time, shorter burst time. So P3 has been given chance to execute. Now, because this is a non-preemptive, it will be allowed to continue its execution and complete. So P3 has a burst time of 6. So starting from 10 plus 6, which is 16. Right now, the current time is 16. And now you are able to see that in the queue, P2 hasn't yet been scheduled. Okay, because P3 was given a chance. So P3 was in the waiting, P2 was in the waiting queue. Now in the meantime, as you are able to see, the current time is 16. So current time is 16. So P4 is also arrived because of the arrival time 12. So while P3 was executing, right? So this has also arrived. Now among P2 and P4, now obviously P1 has completed, P3 has completed, but we are left with P2 and P4 in the wait queue right now. Among P2 and P4, P4 has a better burst time or a shorter burst time, shortest job first, right? So P4 will be given a chance to execute here. And that will continue for only 1 unit of time because of the burst time there. So it will stop at 17. Now, mind you, P5 has not yet arrived because arrival time is 18. So P4 has completed. But system will not currently be idle because there is already one more process which is in the wait queue, P2. And that's the only process right now. So there's nothing to compare. So P2 will be given a chance to schedule. So P2 will run for 7 units of time from 17. That is still 24. And obviously P2 has completed. And P5 is the only one which is remaining. So P5 will be scheduled next for a burst time of 5. So 24 plus 5, that is still 29. Again, as you are able to see, the last point in your Gantt chart will be sum of all these values here, which is 29. You can check that. Okay. Now this is a Gantt chart for SJF. Now again, we will try to compute the wait time and turnaround time, right? So let's see the wait time and turnaround time. My mistake, sorry. So wait time turnaround time. All right. So wait time, like I said, is start time minus the arrival time, and turnaround time is completion time minus the arrival time. That's the formula we'll be using. So for each of these process, P1, P2, P3, P4, and P5, let us try to compute the wait times. So wait time for P1 is obviously the start time. So start time minus the arrival time. So 0 minus 0, that is 0. Similarly, P2. P2 started at 17 minus the arrival time. So that is 3. Comes up to 14. And P3 has started at 10 as per the Gantt chart. Right. So 10 minus its corresponding arrival time is 4 as per the table given to you. Right. So that comes up to 6. And then P4 has started at 16. That comes up to 16 minus the arrival time is 12, which is 4. Right. Then followed by P5 started at 24. So that comes up to 24 minus its arrival time, which is 6. Now we can compute the average wait time, which is sum of all these values divided by 5 process. So that would be 0 plus 14 plus 6 plus 4 plus 6 divided by 5. So that comes up to 20 plus 10, 30 by 5, which is equal to 6. Now, as you must have observed, which is very less when you go for FCFS actually. So FCFS, we had a wait time of average wait time of 7.4. Right. I hope you are able to understand this. So now we have 6. Average wait time is 6 using SJF, shortest job first. Now let us try to compute the average turnaround time as well. So average turnaround time is completion time. So P1 has completed at 10. So that would be 10 minus the arrival time. Then P2 has completed at 24. 24 minus its arrival time. Right. Then P3 completed at 16. 16 minus its arrival time is 4. So that comes up to 12. Then P4 completed at 17. So 17 minus 12, which is 5. And similarly, P5 completed at 29. So 29 minus its arrival time is 18, which is 11. Compute the average turnaround time, which is sum of all this divided by 5. So that comes up to 31, 43, 48, and 59. 59 divided by 5, which is approximately equal to 12. Okay, so you'd probably get 11 point something. I just put it as approximately equal to 12. Okay, again, you can compare that with your FCFS here, which is 13.2, and we got SJF as 12, which is better than your FCFS. Right? That's pretty much about your SJF technique. Now let's move on to the next technique, priority technique in the non-preemptive.